All right, so this is a video of the solutions to the problem solving with right triangle trig worksheet. This is obviously number 1. It says you are a team of miners in central Pennsylvania's coal region. By surveying and testing small portions of the earth, you have discovered a pocket of coal 24 meters beneath a local farmer's ranch house. So I'm going to start out by drawing the ranch house, and it's built on the ground. And there is a pocket of coal. It tells me 24 meters below the ranch house. Then it continues, your team has acquired the rights to mine the earth beneath the ranch, but have not acquired the right to bring your equipment onto the farmer's property. Therefore, you cannot dig straight down from the farmer's house. However, the farmer has granted you permission to dig on his property from a point in his cornfield 17 meters away. Okay, so I'm going to call this the cornfield, and I know that it is 17 meters away. And if we're going to dig from a point in the cornfield down to the coal, we're going to dig along that path. So what we've created for ourselves is a right triangle. And we know parts of the right triangle, and now we're going to be asked to find parts. It says, at what angle to the level ground must your crew dig to reach the pocket of coal? So that angle is right there. What distance must you dig? Well, the distance that we'll dig would be this side of the right triangle. So now I can go ahead and I can find those two things using my right triangle trig. Now remember, right triangle trig is sine, cosine, and tangent. So, ka, toa. So we'll start with the angle that I've marked with x. From that angle, we see that we have the opposite and we have the adjacent sides. So opposite over adjacent is tangent. So I'm going to calculate the tangent of x equals 24 over 17. And of course, we can find what x equals by taking the inverse tangent of both sides. So x is going to equal the inverse tangent of 24 over 17. And we can plug that into our calculator. Second tangent, 24 divided by 17 equals 54.7 degrees. So there's the angle that I'm going to have to drill at. Now to find the distance that I have to drill, I have a right triangle. I know 2 of the 3 sides. I can simply use the Pythagorean theorem. So a squared plus b squared equals, in this case, y squared. So if I take the square root of both sides, that'll give me what y equals. So back to my calculator, I have the square root of 24 squared plus 17 squared. And that equals 29.4. So that's 29.4 meters is how far they're going to have to dig or drill. So here's number 2 on the worksheet. It says the steps to the front entrance of the Mount Lebanon Borough building rise a total of 1.5 meters. Okay, so let's draw our steps in here. Let's draw ourselves a little borough building, and we'll say that the steps sort of come down like this, and we know that the overall height of those steps is 1.5 meters. Okay, and there's of course the ground, which would go like that, and the borough building is built perpendicular to the ground. So you can see our right triangle starting to form here. I'll kind of outline it in red. Looks like this. There it is. Continuing with the problem, it says a city ordinance requires that a portion of the steps be replaced by a wheelchair ramp for handicap accessibility. According to the city ordinance, the angle of inclination for the ramp cannot measure greater than 4.5 degrees. All right, so the angle of inclination would occur down here, it would be this angle. And it cannot be any bigger than 4.5 degrees. Obviously, that's a very small angle because we want a nice small slant of the ramp so that people could wheelchair their way up. It says the town of Mount Lebanon has hired you to build the ramp. What is the minimum distance from the entrance to the ramp where the ramp must begin? So in this problem, they're actually asking us to find this length of the triangle, right? They're not asking us how long is the ramp. They're asking us how far from the entrance or how far from the building should the ramp start. So we have an angle of 4.5 degrees right here. We know the opposite side, and we're trying to find the adjacent side. So opposite over adjacent, again, is tangent. So I'm going to take tangent of my angle equals the opposite side length over the adjacent side length, which is x. And now I have to solve for x. I'm going to multiply by x on both sides. That gives me x times the tangent of 4.5 degrees equals 1.5. And then I'm going to divide both sides by the tangent of 4.5 degrees. These cancel out, leave me with x by itself, and then I can plug that right into my calculator. 1.5 divided by tangent of 4.5. And I get 19.06, we'll round to. 19.06 meters for my answer. Now, one important point to make here. If you perhaps mistakenly solved for the hypotenuse of this right triangle, let's say that you used sine. So from our angle, sine would be opposite over hypotenuse. Well, your answer is going to come out very similar to 19.06. But if you look closely at that decimal, it is a different length. It is a little bit longer. Because our angle of 4.5 is so small, the difference between the length of the base of this triangle and the length of the hypotenuse of this triangle is going to be very small. Number 3, your team of engineers has been hired to build a new bridge across the Allegheny River in downtown Pittsburgh. In order to calculate how long the bridge must be, you go to the site of construction. Standing at point A, the location where the bridge will start. Okay, so before we continue with the problem, we need to think about how we're going to draw our diagram here. We want to draw our diagram from an aerial view looking down on the river. So let's say that this is one river bank, and this is another river bank, and this is the water flowing down the river. So when we go down to the location where the bridge will start, we are picking a point where the bridge will start, standing there on the bank of the river. Now the problem continues. It says, you look directly across the river to point C. Okay, so this was point A. We look directly across the river to point C, the location where the bridge will end. So that red dotted line that I have so far is where my bridge will go. After walking 150 meters up the shoreline, so I walk 150 meters up the shoreline. Let's just call this point B. After walking 150 meters up the shoreline and looking back at point A, you measure the angle from point A to point C to be 58 degrees. So I turn around, look back at point A, and then I measure the angle from A to C. And that angle is 58 degrees. How long must the bridge be in order to cross the Allegheny? Well, there's our bridge, right? So we have to solve for x. So based on the angle 58 degrees, I'm trying to find the opposite side, and I know the adjacent side. That's cosine. So let's do our work over here. We have cosine of 58 degrees equals, not cosine. Opposite over adjacent isn't cosine at all. It's tangent. Not sure what I was thinking there. Tangent of 58 degrees equals opposite side x over adjacent side 150. And now I have to solve for x. So I'm going to multiply by 150 on both sides of this. These cancel out, leaving me with x equals 150 times the tangent of 58 degrees. Bring up my calculator. 150 times the tangent of 58 equals 240. We'll round it to the hundredth, so 240.05. And this is in meters. So that's how long our bridge will have to be to get us across the Allegheny River. All right, the next problem on the worksheet is actually on the back of the worksheet, and the directions say to use the law of sines or the law of cosine. So we have to decide which one to use here, or maybe we have to use more than one. So they're asking us to find h, lowercase h, which is side h, right there. So looking at the diagram, we have angle W, and we have side W. We have angle Y, we don't know, or excuse me, we have side Y, but we don't know angle Y. We're trying to find side H, but we don't know angle H. So, thinking about the law of sines, I could use this angle and this side to set up a ratio, but I can't set up the ratio that has side H in it because I don't know angle H, so that's not going to help me. Thinking about the law of cosine, if I want to find side H, I need to know angle H. So the law of cosine is not going to help me either. In both cases, the law of sines and the law of cosine, I need to know that angle H. How can I find angle H? Well, let's think about this. I can set up the law of sines with the ratio of the sine of 49 degrees over 32. Sine of 49 degrees over 32. And that would equal a ratio of the sine of angle Y over 36. Sine of angle Y over 36. Now what conclusion I'm coming to here is if I can find angle Y and I know angle W, then I can add those two angles together and subtract from 180 to eventually find angle H. Then I'll be able to use either the law of sines or maybe the law of cosines to find side H, which is what they asked me for. So let's use the law of sines here to find Y. So I'm going to multiply 36 times the sine of 49 degrees over 32. So I'm going to do this part of the cross multiplication, and I'll get 36 sine 49 degrees over 32. And that's going to equal the sine of angle Y. Now I have to use the inverse sine of both sides. And that will get me angle Y by itself. So I can plug that into my calculator. So the second sine of 36 sine of 49 degrees divided by 32 equals 58.1. So we'll just call that 58 degrees for angle Y, 58 degrees. So I'll label that over here, 58 degrees. So then 58 plus 49 subtracted from 180. So 180 minus 58 minus 49 equals 73 degrees is angle H. So 73 degrees there. Now I can use the law of sines a second time to find side H. So I can set up a new proportion, sine of 49 degrees over 32, that's the ratio I used previously, I can still use it, equals the sine of 73 degrees over side H. Now I can cross multiply. H times the sine of 49 degrees equals 32 times the sine of 73 degrees. Then divide both sides by the sine of 49 degrees. Those cancel out, leaving me with side H. I can plug this into my calculator. 32 sine 73 divided by the sine of 49. Oh, I better go back here. Put in my parentheses and enter. And H equals 40.5. 40.5 centimeters. All right, the next one, number 5. We're finding the measure of angle E. So angle E is right here. I know side E, so that's good. But I don't know any other angles. I do know all three sides, though. So thinking about the law of cosine, if I'm trying to find an angle, I need all three sides, and I have that in this case. So we should just be able to use the law of cosine here. So we're trying to find angle E, so we'll say cosine of angle E at the end. That means side E has to go at the very beginning. So 350 squared equals 390 squared plus 380 squared minus 2 times 390 times 380 times the cosine of angle E. So there's our setup. Now I'm going to subtract 390 squared over to the other side and subtract 380 squared over to the other side. So that's going to give me 350 squared minus 390 squared minus 380 squared. And that's going to equal negative 2 times 390 times 380 cosine of angle E. Now to get the cosine of angle E by itself, I'm going to divide both sides by negative 2 times 390 times 380. These are going to cancel out, leaving me with the cosine of E by itself. And I have this whole thing that and now to get angle E by itself, I do the inverse cosine of both sides. So these undo each other, leaving me with angle E by itself. And I can plug all of this right into my calculator. So I have the inverse cosine. I'm going to use my fraction, alpha y equals, choose number 1, 350 squared minus 390 squared minus 380 squared. Bump down to my denominator. Negative 2 times 390 times 380. Bump out. Close my fraction there. Hit enter. 54.05. So angle E is 54.05 degrees. All right, last one, number 6. Here we're being asked to find side A. So side A is right there. I'm not sure what that vertical line is, just a little typo. So we are being asked to find side A. We know angle A, that's good. And we know angle B and side B. So we should be good to set up the law of sines here. So we'll do sine of angle A, 79 degrees, over side A equals the sine of angle B, 52 degrees, over side B, 28. Cross multiply and solve. Here we go. 28 times the sine of 79 degrees equals A times the sine of 52 degrees. Divide both sides by the sine of 52 degrees. Those cancel out. A equals, I'll plug this into my calculator. 28 sine 79 divided by sine 52. Enter. 34.88. 34.88 centimeters. There you go. So those are the 6 problems on that worksheet. You certainly can rewind and watch again if you need to, pause, and whatever you need to do to make sure you understand these.